everyone, my name is Chris, and I am an OpenSciEd teacher and facilitator in Connecticut. I'm here to share lesson 15 of the weather unit with you. And lesson 15 has become a favorite of mine for quite a few reasons, but the biggest reason is that during the lesson, my students realize that they can make sense of big data sets by figuring out ways to code the data visually. Your artistic students are going to love this lesson. Let's take a moment to talk about how we got here. During lesson 14, we watched an intriguing weather forecast, and during that weather forecast, we saw that weather systems can be huge, covering much of the country at the same time, and that these systems can move around the country and that produce multiple forms of precipitation. This has left us wondering, how do these giant weather systems form? How do they move? And how do they drop so many different precipitation types from the same storm? On to lesson 15. Let's see what it's all about. Lesson 15 is an investigation lesson. It takes place over 2 days. I've included 60 minutes for material prep. It's especially true if you teach multiple sections of this one. Most of the materials are just paper, but they need to be sorted, and I'll share a little bit more about that in the tips and tricks section. There are no hands-on investigations involved. You don't need any devices for this lesson, and there's no videos, so it's all paper and pencils. As I mentioned, this lesson has 2 big chunks, and it's roughly spread out over 2 days, with each day having a couple of key moments. On the first day, students work with weather maps that show either temperature or humidity data. They learn to color code similar sections of the map to start to define air masses, and then they put the maps in order of a time sequence to see how the air masses move and shift over time. Then on day 2, we layer on one extra set of data during our gallery walk of the colored maps that we made the day before, and that is radar data showing precipitation. The kids don't have to color these. These just get printed up and can be taped up before they arrive. And then we use all of this data in a big consensus discussion to explain how air masses with different temperatures and humidities interact and how they might be related to storms. Through all of this, we figure a bunch of stuff out. We figure out that air masses are large parcels of air, sometimes hundreds of miles wide, with similar characteristics like temperature and humidity. That air masses can move from, most often we see them in the United States, from west to east. And that storms and precipitation seem to develop where the 2 air masses with different characteristics meet, and that this boundary is called a front. Let's talk about some key moments in each of those days and lesson sets. I highlighted part 2 of day 1 as kind of an important day. And it's really important because this is sort of sets kids up for success later on when they have to do some work individually to color code their own temperature and humidity maps. So it's worth it to take a little time here to set them up for success. It's also good because this will help you make sure they have everything that they need. But basically in this section, what kids do is they start off by finding similar temperatures at city locations on a map, and they just color those in with a dot right around the city name or right around the city temperature. Then in the second step of the color coding, they kind of connect the dots, but that ends up leaving some gaps like around the country where there's empty spaces that don't connect easily. So that's when they learn to sort of shade or blend the colors and let them kind of run into one another to show the different air masses. This step is everybody looking at the same map. So we're all doing this together, and they try to do the color coding. Here I have often also kept a blank copy of this under a document camera or up on my smartboard so that kids can come up and color things in or try them out with the whole class watching or participating. to help see those different color patterns emerge. And I can't tell you how many times I've heard them say, "Wow, this is kind of just like color with numbers," right? As they put that stuff together. Um, that brings them eventually to part four, where there are 10 more dates and times all connected. Um, and the kids get together in small groups of two or sometimes three. And each group picks or chooses or is given a certain timestamp. And those times are labeled as time point 1, 2, 3, 4, 5, 6, but they also correspond to basically every 8 hours over 3 days. Um, and this always takes them longer than I think it's going to for some reason, but they do really enjoy it. It's like spending some time with each other, talking about what they're seeing, and coloring maps. And really, it's getting them to where they can look at them in a time series. So a little extra time here has never hurt it. Hurt. Um, I have space issues in my classroom where I don't have long wall spaces, so I tend to do this part, the lining up of all of the maps afterwards in a hallway, and we kind of do our gallery walk out there. One other little note: the color scheme that's suggested for the humidity maps has a lot of different shades of green. I didn't have that many different shades of green colored pencils, so we just recolored them and figured out something different. And you may need to do the same depending on what you've got for shades of green. On day two, the first part is a real challenge for kids. They're really asked to say, okay, where are the big chunks of air or the air masses? And to actually take and either draw them or use a piece of string and outline them. Um, and lots of my kids wanted to just do this by using the original temperature data, and that's the image you see on the top here. But when they did that, they tended to just identify wherever the temperature line separated. Um, where what you really want them to do is to take the temperature map and the humidity map together and say, okay, where is the air warm and wetter, and where is the air cold and drier? And usually, eventually, they get to something like the picture in the bottom right, where they're saying, okay, everything below this line is warm and humid, and everything above this line is cold and dry. I found putting these into dry erase, I'm sorry, putting these into plastic sleeves, sheet protectors, so that kids could use dry erase markers on them while they were chatting with each other was super helpful. And lastly, we get to this section of our lesson that is it's labeled as a 20-minute class chunk, consensus discussion, but it's not really a 20-minute conversation because it is broken up into four distinct parts. But each one leads to the next. So first, we do a class summarings of our noticings and maybe our wonderings about the maps that we've created and the things moving over time, which leads them to sort of individually do a guided progress tracker entry. It's a 3-part progress tracker with sources of evidence and questions that for them to respond to. Then they take some time and they update their initial ideas models, trying to add in the words of fronts and air masses. And if this gets really sticky for your kids, or they don't get the model to look like their teacher's guide suggests, that's okay. They'll have a couple of passes to sort of figure this one out. And then there is a summary of the key ideas that we have figured out. The teacher's guide has really good supports in this one that are really helpful and valuable. And the prompts that I specifically found that were really helpful, one was where we asked the question, where is the storm in our model? And that really got them to thinking about, okay, where is the weather happening in the maps that they did? And there's a final summary points chart that you can pre-make and hang in the room. And you might even have kids add this to their notebooks. Couple of materials management things here. I made a set of slides for the colored time series so the kids would have some instructions up there on the board while they were individually trying to do that. I also made some time and date index cards, so when they were done with their maps, they knew where to put them. I made sure I pre-sorted the time series maps into 10 groups So two maps together, one humidity and one temperature map to one set of students. And then give them some tape while they're coloring, and that will help them take them up to the wall when they're ready. Um, as for words that we use in this, there's a couple that come up. Air masses is one, and we learned to define those using air masses using temperature and humidity. There is front or frontal boundary, where the air masses meet. And then I found some of my kids curious about radar. They weren't really sure what it was, but they knew that people used it for weather. And then humidity and temperature come up from previous units. We do need a few things from our previous lesson to still be around: the new initial ideas model, our new driving question board questions, and our ideas for investigation. And then we create a bunch of stuff here too. The time series for temperature, a time series for humidity, a time series using radar images, noticing and wonderings from our time series maps, and a little summary of the ideas that we are thinking about and have figured out from this lesson. So I hope that helps you a lot to find out what comes next and be ready for the next lesson. Go ahead and check out the lesson 16 video.